So here's our chapter 6 notes. We are going to kind of skip subjects a little bit. Kind of looks vectorish, but we're not really talking about vectors anymore. That was just 2 sections, and they're done with that. So we're going to talk about the trigonometric form of a complex number. So sounds complicated, really is not that complicated. Okay, so the first thing that we're going to talk about is what is a complex number. So remember that a complex number, hold on, let me just double check that I did everything right here. I shared my screen, right? And I'm broadcasting. Okay, we're good. Okay, so the first thing is, what is a complex number? So remember, a complex number is when you write a real part of a number, and then you add the complex part of your number in the imaginary scale, and voila, we have a complex number. Okay, so you can see down here some complex number. The general form is a plus bi. Okay, I don't think we've actually explicitly done this, but it's pretty easy once you see it. You can graph complex numbers just like you would graph on a coordinate plane. It's just that your coordinates are different. So what I mean by this is your real axis and this is your imaginary axis. Instead of your x and your y, now you have real and imaginary. Okay. So if, for example, oh, it's already plotted on there for me. Somehow I must have known that. So here is where you would plot the complex number 3 plus 2i. So it would be 3 units of the real number and 2 units of the complex number, and you get a point at 3, 2 on the imaginary, complex number plane. Okay. I think that's pretty easy. Again, if you have a complex number that's -1, 3, then your point would be at -1 on the real coordinate and +3 on the imaginary coordinate, and you just plot it on there. I was looking right before you guys hopped on. I was looking on my phone, so I know that this isn't crazy to do. If you go into Desmos and you type Desmos imaginary, or yeah, they do have imaginary plane. Okay. So complex plane or imaginary plane, they just have a basic, it's not a separate calculator for it, but if it loads, you'll see. I even like their description. It says, every complex number can be expressed as a point in the complex plane as it is expressed in the form a plus bi, where a and b are real numbers. Okay, so by using the x-axis as the real number line and the y-axis as the imaginary number line, you would plot the point as you would xy. So for example, if, I don't know what, oh yeah, a is your real part. So if, again, in that example, if we had 3 and 2, will it plot it on here for me? Oh, maybe I have to hit play. Okay, I don't know what it's doing. I don't know where it's going. Anyway, yes. So real, imaginary, just like x and y. Nothing too complicated with that. All right, we'll just turn that off because I think I don't even know what I was doing. All right, so that's one part of it. The first thing is called, the first blue box that you have on your notes is talking about the definition of the absolute value of a complex number. Okay, the definition of the absolute value of a complex number. So basically, we can take the absolute value of a complex number, and it looks a whole lot like the Pythagorean theorem again. Just like when we were talking about vectors, the Pythagorean theorem came back into play. Finding the absolute value of a complex number is just like using the Pythagorean theorem to find it. So you're finding basically the value of the vector that would go out to that point. Okay, so we'll kind of come back to those, but For example, it says in 1 through 8, plot the complex number and find its absolute value. Okay, so plot the complex number and find its absolute value. So the first ones of these are actually really easy. Okay, so the first one is, again, 3, 4, 5, 6, 7. So if you look at number 2, this is your real and this is your imaginary axis, right? If I look at number 2, it says to plot negative 2i. So negative 2i has 0 real parts and only imaginary parts, and it's negative 2. So this would be at 0, negative 2. Okay. If I wanted to know what the absolute value is, I could do it algebraically, but this is actually a really easy one, right? The absolute value of this is just going to be 2 units. So the absolute value, or the absolute value of negative 2i, is going to be 2 units. So I can look on my graph and see that. I could also do it algebraically by this formula. Okay, so the absolute value of a complex number is equal to the square root of the square of the real part, which is 0, plus the square of the imaginary part, which is negative 2. So negative 2 squared is 4, and the square root of that equals 2. So pretty easy peasy, right? If I wanted to plot number 4, 7, right? That's 1, 2, 3, 4, 5, 6, 7 on the real plane and nothing on the imaginary plane. So this would be a point at 7, 0. Any guess what the absolute value of this would be? So the absolute value of 7 is 7, right? So then number 6 gets a little more complicated. Not crazy though. So we have negative 5, negative 12. I did not make my coordinate plane big enough for that. Okay. Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, this is messy. Okay, so if I'm going to plot number 6, it's going to be a real component at negative 5 and a complex component at negative 12, which is right down here. My lovely graph, right? Negative 5, negative 12. Okay, if I want to find the absolute value of that, I'm going to do a little bit of math, and I'm going to add a little bit to my page. Okay, so the absolute value of negative 5 minus 12i is basically going to be the Pythagorean theorem, right? You're going to take the square root of negative 5 squared plus negative 12 squared. Okay, and if I do that, I don't actually, oh yeah, it is. All right, so then I get 25 plus 144, which happens to be square root of 169. So the absolute value is 13. Right? 13 units is my absolute value of my complex number. Okay, that's not so bad, right? First box, we're good to go. Everybody good with that?
Yep.
Cool. Mackenzie, Greta, you guys good?
Yep.
All right, cool. All right, so now we're going to talk about the other part that's a little bit more complex, but still not crazy. Okay, so now we're going to talk about this thing called the trigonometric form of a complex number. So remember, we spent all that time before break talking about the unit circle and all that fun stuff that goes along with it. So this is kind of just a formula that's going to help us write the trigonometric form of a function. So it seems a little weird, but You'll get it. Okay. So the trigonometric form of a complex number is your regular number is a plus bi, so your real part and your imaginary part. Okay. You can write that in trigonometric form instead, so these are equivalent to each other, as z equals r times the cosine of theta plus I times the sine of theta. You're like, whoa, whoa, whoa. Wait, we went from just like simple complex number to now we have some r value and sine of theta and cosine of theta. Yay, right? Well, r, if you look at r here, r is basically what we were doing before, where we were finding the absolute value of a complex number. But when we're calling in the trig form, r is going to be our modulus of z. Okay? So we can find r by basically taking the Pythagorean theorem, or the absolute value of our complex number. Okay? The number a is going to be that number times the cosine of theta, and b is going to be r times the sine of theta, and the tangent of theta is b over a. So theta is called the argument of z. So I feel like I just spewed a bunch of words out at you, right? But really, once you get used to it, it's not that bad. Okay, so we're basically rewriting complex numbers in trig form is what we're doing. Okay, and we're going to do that by using this value, the modulus, and we're going to use the argument. Not modulus, modulus. Sorry, I always want to add something there. Okay, so let's kind of do a couple of these so that you can see what it looks like. Okay, so right here we have a complex number. It says write the complex number in trigonometric form without using a calculator. You always do that, right? Don't use your calculator. I'm going to take this and move it up so that we can be closer to what we are trying to do here. Okay. Okay, there we go. So if I just wrote this as a complex number, right? This complex number would just be z equals 4. Oh, it actually says it right there. Z equals 4. So that there is actually no even, what's it called? There's no complex part to this, but we're going to write it in trig form. Okay, so what is the absolute value, or the r value for this? So the absolute value for the r value is basically you're going to take the real component and square it, and add it to the complex component and square it. Well, in this case, there's no complex component, so it's really going to be the square root of 4 squared, which is just 4. So you could probably just look at the formula for r, and tell me that it equals 4, right? Okay, now let's look at our theta, our angle. Okay. Again, you might want to bring out your unit circle for this too. So let's look at our theta. The theta represents the angle at which your complex number is from 0. So in this particular case, this one's super easy because we can look at it and say that our theta, we have basically no angle right now, right? Our theta equals 0. 0 degrees, right? It's not going anywhere. So if I was to write this number in complex form, I would say that z equals, and so now I'm going to kind of put it all together. Z equals our r value, which is 4, times the cosine of 0 degrees plus I times the sine of 0 degrees. Not theta, of 0 degrees, sorry. Okay. Now let's think about what this actually means. If you have your unit circle, right, the cosine of 0 degrees is 1, and the sine of 0 degrees is 0, 0i. So if you actually multiply this out, you're going to get that z equals 4 if you evaluate what the sine and the cosine are. Okay. So then let's look at number 12. Guys, all right so far? Let's look at number 12 here. So 12 is z equals negative I, right? So what would my absolute value or my r value be? So my r value is going to be 1, right? Because it is going to be the square root of 0 squared plus negative 1 squared, which equals 1. So my r value is 1. I got that, right? What about my theta? What is my angle if I look at this on a graph? So if I look at this on my unit circle, right? This point is if I go all the way around my circle to here, and that's when my theta equals 3 pi divided by 2. Okay, so if I was going to write this in trig form, complex number in trig form, I would write it as z equals z equals 1 times the cosine of 3 pi over 2. I can't talk and write apparently at the same time today. Okay, 1 plus that, plus I times the sine of 3 pi divided by 2. So if I actually look at this and I look at my unit circle and I see what if I evaluate the cosine of 3 pi over 2, the cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is negative 1. So if I multiply it back out, so I'm saying the cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is negative 1. So if I multiply this all back out, I end up with 1 times 0 plus, well, negative I, or just negative I. So it multiplies back out to the complex number. Okay? Everybody good so far? You're like, great, I get to write something the same exact way, right? All right, so let's look at 16 where it's not quite as straightforward. All right, again, we're supposed to be doing this without using a calculator, which is fine. We can totally do these without a calculator. So 16, I don't have a nice, easy R value. I have to actually evaluate it, right? So R just equals the square root of the real part of this number. So my number is negative 1 plus square root of 3i. So negative 1 squared plus square root of 3 squared. Okay, so my absolute value, my R, my modulus is going to be 1 plus 3, or the square root of 4, or 2. Okay, so I know my R value is 2. Now, how do I figure out the angle here? How do I figure out the angle here? This, I really can't look at that easily and tell you exactly where that's at, but there is a second part of this, okay? The second part of this is that, well, there's a couple different things that you can do. The part that we're going to use is that the tangent of theta equals b divided by a. So remember, b is your complex part and a is your real part. Okay. So if I do that and I say that the tangent of theta equals my complex part, which is the square root of 3, over my real part, which is negative 1, I get that the tangent of theta is equal to negative square root of 3. Okay. Again, I'm going to go back to my unit circle. I got my unit circle here. I should have one to pull up. Go back to my unit circle and I'm going to look and see where on my unit circle does the tangent equal the square root of 3. So remember, that's where your sine divided by your cosine equals the square root of 3. And in this case, the theta is going to be at 2 pi over 3. So I found that by looking at my unit circle. Okay. So once I find my theta, then I can write this out. My complex number in trig form is z equals 2 times the cosine of 2 pi over 3 plus I times the sine of 2 pi over 3. Okay, and then if I go back and I want to check my work, okay, what is the cosine of 2 pi over 3? The cosine of 2 pi over 3 is negative 1/2, and the sine of 2 pi over 3 is square root of 3 over 2. Okay, if I distribute my 2, I end up with negative 1 plus I times the square root of 3. So I'm back to my original complex number up here. So this is what your answer would be. This is the trig form of your complex number. Okay? Everybody good? It's very exciting. Okay. So the nice thing is that's pretty much it to the chapter. We're going to do, for this section even, we're going to do some more examples, but we're doing pretty good. Okay. So in 17 through 36, represent the complex number graphically and then find the trig form of the number. Same thing, they just don't give you the graph. They just kind of skip right to the good stuff, right? Let's move that up here. Let's get rid of that. Let's get rid of that. There we go. All right, so let's see. Let's do number 22. Okay, so 22 is we have, I always do that. 22 is we have 5 over 2 times the square root of 3 minus I. So the first thing I'm going to do is I'm going to go ahead and distribute my 5 over 2. So I have 5 square root of 3 divided by 2 minus 5 over 2I. Okay, so if I want to graph that, I'm just going to use Desmos to graph it. So if I wanted to graph my point, I have a point at 5 times the square root of 3 divided by, what was it? Divided by 2, right? That's your x coordinate. And then your y coordinate is just 5 divided by 2. Okay. So if you were going to graph it on a imaginary, a complex number plane, right? This would be your real part, and this is your imaginary part. So your real part is at approximately 4.33, and your imaginary part is at 2.5, right? 2.5. So that's where it's graphed at. So this is where the problems before, you could kind of look at them and see where they were, what this angle is. I have no idea what this angle is, what that angle is going to be. I have a guess, but I don't really know what that angle is going to be. Okay. So let's figure out how to write this in trigonometric form. Okay, so back to here. So first thing I have to do to write it in trigonometric form is to find my R value, which again, you're going to basically do Pythagorean theorem, right? So this will be a fun one. We have 5 square root of 3 divided by 2 squared plus 5 over 2 squared. Okay, I'm really inclined to just use my calculator for this, but we're going to do it. Okay, so 5 squared is 25 times 3, because square root of 3 squared is 3, over 4, right? You got to square everything, plus 25 over 4. And how about that? We end up with basically 75 plus 25. So this is your fraction skills here, right? You get 100 over 4 square root, which is the square root of 25, which this actually has a nice R value of 5. So square root of 25 is 5. Never thought that would happen, right? Okay, so now I need to find my argument, my theta. So your theta, okay, is going to be, you can find it a couple different ways. I tend to just go right for the tangent because that's the easiest one. You could also find your theta by using one of the other two values. All right, but I think it's just easiest to remember this. The tangent of theta equals your complex number, which is 5 over 2, divided by your real number, which is 5 square root of 3 divided by 2. So what's nice when you write this fraction out is that you get to cross the 5's off and you get to cross the 2's off, and you're left with the tangent of theta equals 1 over the square root of 3. Okay, so then if I look at my no, I don't have that on my unit circle. Oh, you know what? I do have it on my unit circle. I think I did something wrong when I graphed my thing. I'm looking at my graph and I'm like, what? This should be negative. There was a negative out front in here. So I'm looking at my notes. So that works a little bit better with what I'm trying to do. So this is where it's at on my unit circle. So now if I kind of look at my unit circle and I see where is the tangent equal to 1 divided by the square root of 3, which is also the same as square root of 3. Basically, if you look at that for your tangent of theta, you're going to find that theta equals 5 pi divided by 3, if you look at your unit circle. I'm actually curious, because I just did it that way. I'm curious if we would use maybe if we use like the sign, if that might actually work better. So what I mean by that is if you take the complex number, the b, so which is negative 5 over 2, right? So this should have been a negative in here this whole way. That was my problem. I was leaving that out. If you take negative 5 over 2, it should equal your R value, which is 5, times the sine of theta. Okay, so that means that I can divide 5 out from both sides, and I get that the sine of theta equals negative 1/2. And that's actually much easier on my unit circle. That would actually be 11 pi over 6. I'm wondering if I wrote something down wrong on that one. Maybe it's 11 pi over 6. It is 11 pi over 6. It's not 5 pi over 3. Theta should be 11 pi over 6. I'm looking at my unit circle here. To see. So I guess what we can do is we can put the complex number into Desmos and see if we got it right. Of course, I picked the one that I'm like. So what I mean by that is that my complex version of this number should be 5 times the cosine of 11 pi divided by 6 And then if I'm going to write this times the sine, nope, it's not going to let me do that. Sorry, guys. Give me just a second here. Let me see if I can get this to graph correctly. There we go. All right, so I apologize because I had it written down wrong in my notes, but this is the same point. I don't know if you can see that. They're in the same spot. So maybe we should do another one since I kind of messed that up as I was explaining it. But basically, this is kind of where I got messed up. I forgot my negative sign. And then when I was looking at my unit circle for where is the tangent of theta equal to -1 over the square root of 3, I looked at the wrong value. Their value should be 11 pi over 6. But actually, the more I'm looking at it, I think if you take the sine or the cosine, it's much easier. Because if I know that my sine of theta equals -1/2, then it's really easy for me to look at my unit circle and find that that's where theta equals 11 pi over 6. Okay, did I completely lose you guys?
I don't think so.
Okay. Did you see where I went wrong? Don't do that. Okay. Let's see. Which one should we do? Let's just go for it. Let's just do number 36. So some of these values, so the first few values, you're actually going to end up with a nice, exact value. Some of these values toward the end, you're going to end up with not as nice of a value. So what do I mean by that? Let's see here. Really big? Nope, that didn't work. There we go. All right. Maybe I should have just erased and started over. Oh, go away. Almost covered, not big enough. Okay, number 36. We're going to do number 36. And this will probably be our last one for today. Actually, 37 through those are actually easier, I feel like. So we can look at those, but I lied. We'll do 2 more. We'll do 36 and 1 more after that. Okay. All right, number 36 is -8 minus 5 square root of 3i. Okay, so first thing we got to do is find the r value. So r is going to be square root of -8 squared plus the -5 square root of 3 squared. Okay, so we're going to get 64 plus 25 times 3, which is 75. And 64 plus 75 equals the square root of 139. Blah, right? I don't think you can simplify 139. I don't have it simplified. I know it divides by 3. I don't think it divides by 9. 139 divided by 9. No, it doesn't divide by 9. I think that's as simple as that's going to get. So your R value is going to be square root of 139. All right, so then if I want to find my theta, I can do this a couple different ways, right? I'm going to go ahead and go not on my notes, and I'm going to find theta, and I'm going to use this part. I'm going to use that the real part equals the r value times the cosine of theta. Okay, so in this equation, -8 is my real part. My r value is the square root of 139 cosine of theta. Lovely, right? So I'm going to divide both sides by 139. And this is one of those cases where you know that -8 divided by 139 is not going to be on your unit circle, right? This is not going to be on my unit circle. So basically, I have this equals the cosine of theta. So in order to figure out what theta is, I am going to take the inverse cosine of both sides, right? So I'm going to take cosine inverse cosine theta, and that's going to leave me with theta. And on the other side, I'm going to take the inverse cosine, and I'm going to plug it in my calculator to figure out what theta is. Okay, so theta is going to be, and we're working in radians, right? Desmos is in radians. So theta is going to be inverse cosine of -8 divided by the square root of 139. Okay. -8 divided by the square root of 139. So then we get a theta value of 2.316. Okay. I also want to double check and see what I get when I do my tangent. So if I do the tangent of theta, the tangent of theta equals your complex number, which is -5 square root of 3 over -8. Let's see what we get when we do that. Okay, so if I do the inverse tangent of -5 square root of 3, and I'm going to divide that by, nope, I'm going to divide it by -8. Okay, I get 0.822 something. All right, so that's interesting, right? What happens if I do... This is what I get for doing problems that I haven't done actually on my homework, right? What happens if I do the sine? If I do the sine. So if I do the inverse sine of -5 square root of 3. Oh, I get undefined. That's good. All right, guys. What did I do? I got that number right. That should be typed in there correctly. What if I just take out these negatives here? Because I know that they're negative and negative. Oh, here I forgot to divide by the r value. Sorry, I forgot part of it. Okay, so I'm getting a whole lot of values that are sort of near each other, but not quite near each other. So what's going on with my thing here? So let's see what all of these values actually mean on a unit circle. So on a unit circle, I know what I'm going to do. I'm going to switch to degrees. Okay. So I'm getting a couple different values here. I'm getting that my theta, so where was my original point at? My original point was at -8, -5 square root of 3. Okay, this is where my point is on my graph. So let me scroll out here so we can see. It's down here. Okay, so my values that I came up with are 47. So this looks like it's about at 45 degrees from here, right? So one of them, the tangent told me that it's 47 degrees positive. One told me that it's 47 degrees negative, and one told me that it's 132 degrees, which would put me somewhere over in here. So what's going on? Why do I get all these different values when I put in different things? So what's going on is, remember when we were talking about taking the inverse sine, cosine, and tangent of a value? Sometimes because it's only valid for a limited range, you might have to go to the next period that that is available. So what I mean by that is, for the tangent of theta, I might need to take the tangent of theta and then go to the next period, which means adding pi, or since I'm in degrees, adding 180 degrees to that. Okay. So that would take me to a theta value of 227 degrees. In the cosine case, it might be a matter of adding 90. I don't know why did I type something wrong with that? I don't know why that one's off like that. Or in this case, it might be the case of adding 360 degrees. What is going on with my numbers today? All right, guys, I did something totally wrong with this and I can't figure out what it is. Maybe I need to subtract 360. No, that's not helping. I know what I'm trying to say, but my numbers are not working out for me. Did I type something wrong? 5 square root of 3, 18. Did I forget a negative? That should be right. This is why I should not pick problems that I haven't done before. There's something that I did that's throwing this off, and I can't figure out what it is. I feel like I'm wasting your time kind of going over this problem. So I don't know if I confused you guys or helped you more doing this. That's what you should be doing. I don't know what happened with 36. I'm going to have to rework 36 and do that on Monday, because that's going to bug me that I didn't get that one right. Generally, that should work out. I know it has to do with something when you're taking the tangent and sine and cosine where the period is coming out wrong, but I'm not quite sure what that is at this moment that's doing it to me. Something is throwing it off with when you're doing it. But basically, for the other problems, I've done most of the other problems. And as long as you kind of following these steps, then you should end up with the right angle for your complex number. But for some reason, 36 is not working out for me. So I don't know what's going on today. But it looks like class time is almost over. So I guess we'll have a tiny little bit to finish up on Monday when I figure that out. You probably can go ahead and do most of the homework and be fine. I will go ahead and send out the test. So remember, the test and all the homework will be due not this Monday, but the following Monday, which is the 18th. So your chapter 6 test and homework will be due on the 18th. So I'll do a little bit more of this on Monday, but we'll go ahead and start chapter 7 too. So again, sorry about that at the end. I don't know. Maybe my brain's like getting mushy or something, um but yeah, that's kind of what's going on with that. So thanks for coming today, guys. Sorry that, like I said, I'm like, I'll figure it out and I'll let you know.
Thank you.
All right. Thanks, guys. Have a good day.
Thanks. Bye.
Bye, Mackenzie.